Hello, this is a video about the Qibec 1-bit 1 instruction transistor CPU. You can see an older version here and a newer version here. The main purpose of this project is to present an educational, simple, transistor-based CPU having one native instruction operating on 1 bit at a time that is totally impractical yet works, and it can execute your own software, so it's basically meant as an educational project. The details about the old existing version are already given in different videos, so I'm not going to do that here, but in this video we'll focus on the differences between the old and the new version. So let's take a look at the old version first. It's a fairly square baseboard with no intelligence and a number of plug-in modules that you see here comprising the digital logic of the CPU. So these plug-in modules together form the CPU. This is also a plug-in module, but it's not part of the CPU. It is basically a serial display. So an LED display behind the serial controller. This module is also not part of the CPU. It forms a bridge between a host PC and the digital logic of the CPU. And in this version you need a host PC to implement the RAM and the ROM. So every instruction cycle, when this CPU wants to change data in RAM or read new program data from ROM, it asks the host PC through this connection. Has a USB connector right there, and you always need a host PC in order for this CPU to run. Also, you can connect controllers to these connectors to, for example, play a game and to provide input to the CPU. So that was the old model. Let's take a look at the new one. That's this. The first thing you may notice is that it's smaller and rounder, may look a bit nicer. The enclosure is made of one single sheet of acrylic, so it's laser cut, nice logo engraved in it. There are two bend zones, one you can see here, one you can see here. So using hot air you can shape this into this enclosure that you see here. Display may look a bit nicer, it's put at an angle instead of 90 degrees with the previous model. The display is made out of LEDs on the baseboard. This is the baseboard. And light pipes that you see there. Right, light pipes end in a diffused sheet of acrylic right here. So you basically have an LED display. I changed the 16x16 matrix to 8x8 matrix because that's sufficient. The basic design of the CPU is the same. You still have plug-in modules that you see here forming the digital logic of the CPU. So all these modules together form the digital logic of the CPU. However, in this case you have descriptive illustrations on the PCB. For example, this is an inverter, this is a gate, multiplexer I think, this is a latch. Likewise, this is a multiplexer, this is an increment unit, and so on. Furthermore, the biggest difference between the old version and this one is that this can run completely standalone. So this cable is going to a USB supply and not to a laptop. So to do that, where the previous CPU needed a host PC to emulate the ROM and the RAM, the emulation of ROM and RAM, or rather the peripherals that the CPU wants to see, are implemented on the baseboard. So this baseboard acts as a computer system around the CPU. The controller inputs are also integrated on the baseboard. Here you have one button as input, here you have another button as input. Right now it's running in a demo mode, like the previous CPU also had a demo mode, this one also has a demo mode. However, this program actually runs on the CPU. It's a very simple version of Space Invaders. I think you saw this before maybe. The two inputs are used to shoot upwards, and if I win then you know that by this thing exploding. So that's how it works. This is just test software, however I implemented a few things. For example, you can make the clock speed lower. I'm not sure if this shows nicely on the camera, but the flashes are too short. Whenever this LED flashes, means one instruction cycle is completed, and you see the LED showing the bits slow down. You can also put it in single step mode. Right now it's in single step mode, and using this button you can cycle through each program. You also see the state of the LEDs change each time you press the button. You can also micro step it. The CPU uses a 3-phase clock, which means 3 clock cycles are used for one instruction cycle, and you can step through the microcycles here, so you have a higher resolution of execution. So yeah, that's basically how it works. And I don't know what to do with it now. It's on a bit of a hiatus. It's meant as an educational tool, but I'll have to see what I do with this. Maybe sell it as a kit. That was the whole idea. So I hope you like this. For more information, please check the qibec.org site. That is quebec.org. And thank you for watching. Goodbye.